Good afternoon, everybody. I'm pretty confident you were listening to Rick and I have a little banter there while you were waiting. I'm Steve Fahey from ZenTek Consultants. I'd like to thank you for joining us today to see how you can optimize tin surfaces from massive point clouds with BricsCAD. A couple of quick updates before we get started. I just want to let everybody know that where it's a public event, everybody will be muted. If you have any questions during the presentation, please go to the control panel, enter your question. We do have a Q&A scheduled at the end of the webinar, and we'll try to get to as many questions as we can. As mentioned, we are ZenTek Consultants. Brics is a lead partner for US and Canada. We focus on assisting companies within the AEC market to maximize the return on their technology investment. We achieve this by continually developing and delivering innovative solutions to help increase our clients' productivity. I ask you to take a look at our website to learn more about the products and services and see how they can help you. For today's webinar, I'm pleased to have Rick Ellis from Brics join us. Rick has almost 30 years experience in the civil survey industry, and he's going to show us how BricsCAD can be an invaluable tool to your existing civil workflow. So I'm going to share the screen with Rick now and let him get right into the products.
Great. Well, thank you very much, Steve.
You should see it now.
I should be able to share my screen. And all right, so Steve, can you see BricsCAD on my end?
I can.
Okay, perfect. And I know I've got my webcam turned on. Certainly, if you all are watching this and don't want to look at me, would rather see BricsCAD in full screen, I certainly understand. That's what I would be doing if it was me on this. But I've got a few things that I'm really excited to show you all here. Particularly, the main focus is going to be on building surfaces using these large data sets, massive data sets that may come from point clouds, any way that they would be collected, whether that is via flying for a LiDAR scan, using drones, terrestrial scanning, even bathymetric surveys. I mean, when it comes down to it, they're all just massive amounts of points, and how can we deal with those in a CAD product that maybe wasn't necessarily originally designed to deal with tens or hundreds of millions of points. And knowing that we need to get a tin surface out of that to do general civil survey design work with that. So a couple of things real quickly, just to kind of set the stage a little bit. I'm showing this to you on BricsCAD version 23, technically 23.2, which is the maintenance release that came out about a month ago. And everything I'm going to show you is part of BricsCAD Pro. I know there's different levels of BricsCAD licensing. This is all part of BricsCAD Pro. It's also part of BricsCAD BIM and Ultimate if you wanted to go to the for those additional features. But what we've done on the civil survey side of things is focused on some really core functionality that most all civil survey users would need to use. And most of that focuses has been on the tin surfaces initially. And we provide not only this as part of the product to you as end users, but make it also available to our partners who develop third-party applications that will ride on top of this. So if you need some, really advanced civil design tools, something like civil site design, we work with them very closely on providing that, and that's part of the platform strategy that we have. To show you just a little bit of the interface, if you haven't seen it recently from BricsCAD, BricsCAD now has the Civil Explorer here on the left. Kind of looks familiar to things you'd see in other programs, but just as an example, I can expand, and I've got a drawing here that has a number of surfaces in it. I can go find any one of those surfaces just by right-clicking on it and either selecting it or zooming to it. and it zooms me up on that surface. And I even have a visibility button right beside that, so I can toggle that surface on and off. I don't have to go in and create specific styles to do that or anything. It's just a one click right there. And this works for surfaces as well as alignments and profiles and other options. To switch over to a different drawing, just to show you some of the basic surfacing tools that we have. Because when we start talking about point clouds, yeah, there's some really unique things that we want to do there, but also it's still a surface and it's still data that we're going to interact with in that very similar way. So what I want to do is just look at a more traditional surface here. I've got just points and break lines on my screen. They're technically right now, they're in a 3D view, but I could do this in plan view as well. And to build a surface, all I need to do is go over to the Civil Explorer, right click on tin surfaces and pick create. And at the command line, it just asks me to pick the objects. Now, this lets me pick both points and break lines all at the same time. And when I pick those, BricsCAD is smart enough to know at the command line, it says, your selection that you just made contains linear entities. What do you want to do with these? Do you want to just treat them as points and get all the vertices and use that? Or do you want to use them as break lines? So I'm just going to use them as break lines, and we can see there it just built the surface for us. And I'm going to switch over to plan view just so we can see that in a way that you might really expect a little bit more. Now, if I expand tin surfaces, here's that new surface, excuse me, that I made, surface 1. And when I select it down below in the Civil Explorer, we can do things like change the name and give it a description. I can see statistics about that, number of points, number of triangles, and so on. But this button for the definition is really important. You can see that we added drawing objects for the points and then break lines as well. And we could go back and edit any of those. I can also clean up this boundary around the surface. Now I could have given it an actual boundary line. I could add a polyline as a boundary to stop my triangulation there. Or I can delete lines individually by just right-clicking on the surface, going to edit, and you'd see you have your commands that you would expect here: delete line, swap edge, remove outer edges. I also have add point groups, add points, add break lines, add boundaries, remove points, and so on. So if I just did delete line, selected a few of those, you can see that'll clean up that edge. It also added under the definition down at the bottom of the Civil Explorer, this delete edges definition. And I can right click on that and I have an option to disable it and basically just turn the triangles that I just deleted back on. So I toggled on and off the deletion. And I can then re-enable that if I wanted to. If I really wanted to get rid of that, I could then delete it. And by deleting the deletion, so to speak, we have added those triangles back. Now, another way we have to clean up the edges that is a little bit more unique is if I right-click on surface 1, go here to edit, and pick remove outer edges. Currently, this prompts you through a few things at the command line. That'll change in the future with a nice dialog box, but for right now, it's just a command line. But it says, do you want to use a maximum triangle length? And I know a lot of programs have this option of using a maximum triangle length to delete triangles in a surface. The problem is sometimes some of those programs will delete interior triangles that are longer than that as well, creating holes or voids in the tin. This will only work on the outer triangles. So I'm going to say use maximum triangle length, yes, at the command line. For my maximum triangle length, I can type something in, or I can just pick something graphically. Then it asks me if I want to use a minimum length or a maximum angle. I'm going to say no to both of those options. And you see it went and cleaned up a number of things around the surface, or a number of those triangles around the edges. Now, it really didn't do enough for me. Now, this is where it's pretty fun, is we can go back to the definition and I can see remove outer edges is there. So if I just double click on that, it brings up the definition and it shows me the length that I picked graphically was like 439.9999972 feet. If I didn't want to do that, I could just turn it off, or I can turn that back on and I can say, well, what's it look like if I really shortened this up to like 50 feet? And that was obviously way too much. We can see we deleted a lot of things out of the surface that we didn't want to. However, still, it only deleted from the edges. So that was good, but I'll change it back to maybe 100. And that looks a lot better. That gives me a nice clean edge around things. Now I could still go do delete line and flip face and modify things if I wanted to there. The one other thing I want to show you while we're talking about editing this surface data is the break lines. And to make those show up a little better, I'm going to go to the visual style area of things. And I'm going to turn on contours and turn off the triangles. So I'm showing a contour interval of 1 and 10 that are red and green that you could change here. And these yellow lines are the break lines. If I go back to the definition and go to the definition for add break lines and just double click on that, I get a list of all the break lines that we added to the surface. And if I wanted to figure out which one of these was this particular break line, maybe from the drawing, I can use this button to pick it from the drawing. Go ahead and I'll pick this 3D polyline, and it shows me that's break line number 41. And we could have went the other way as well. I could have right-clicked on it and either zoomed to it or just selected it to highlight it. It's not a special object in this case. It's just a 3D polyline, but it's been tagged as a break line. It's part of the surface. So if I wanted to, I could stretch it around and you can see that it would update dynamically. I can undo and put that back. But if I wanted to maybe remove that as a break line, or remove the break line definition for that one line, but not delete the 3D polyline because I still want to keep it, I would just need to find it, so we know it's 41 in the list. And if I right-click on it and pick remove, it will remove the break line definition for that 3D polyline, but it won't delete the 3D polyline from the drawing. So if you watch in that area, when I click remove, now you can see the surface updates and it no longer is respecting that 3D polyline as a break line. So a really nice tool to be able to go through and find your surface data, find any errors, make changes, and update those. Now, all of that information is going to still apply to the surfaces that we might make out of a point cloud. And most likely, all of you that are on the call here, because that's what it was really advertised as, have ran into this problem of we can create and collect massive amounts of data, easier all the time. We could, the cost of drones and LiDAR and scanners continues to go down while the hardware continues to get better. And most of those products all come with some sort of software that views the point cloud very nicely. But if you're being asked to come up with a tin surface, that's much more challenging because you simply can't throw 500 million points into a tin surface and have anything that you could use. So I'm going to start totally from scratch here. I am going to go out and create a new drawing. For my template, it's empty. I do need to save it before I can attach a point cloud. That's just part of the process. I'm just going to call it PC1. And then I'll go to the point cloud tab on the ribbon and attach the point cloud. And I have a choice at the command line of either attaching a file or a folder. So if you have a bunch of point clouds all in the same folder, they can all be attached at once. I'm just going to do a single file, and I'm going to grab an LAZ file that I have. Supported file formats are, most all of the common ones. You have everything, LAZ, LAS, E75, PTS, PTX, recap files, RCP and RCS, and also the hexagon file format HSPC is now in here. So all of those, anytime that I just attach those, it's going to ask me about where I want to attach it. I'll just leave it at 0, 0. And it's going to process this in the background. If I just zoom extents from here, we'll see that I have a point cloud attached now. That point cloud, it's probably kind of hard to see since it's all in black kind of on the screen. I'm going to go to a color map and just tell it to color it by elevations. So that we can see these higher parts and lower parts here colored separately. And what happened there when I attached it was it converted that LAZ file into the hexagon file format or the HPSC file format that BricsCAD uses, and that allows us to have a really high performance through here. I don't know how well this is showing through the GoToMeeting webinar stuff, but I can drag this around real time.
It's very smooth.
Okay, good. Sometimes I was on a Zoom call a month or so ago with people, and it really didn't do it justice that I could move around as freely and easily there. If I pick it, it's going to show me in the properties window that this point cloud is 6.4 million points. Not a huge one, obviously. We can work with stuff much, much larger than that, but for this example, it'll be pretty good. Now, to turn this into a tin surface, I'm going to go to Tin Surfaces, right-click, and pick Create, just like we did before. And at the command line, I'm going to tell it, I'm going to create it from a point cloud. Then I'll pick that point cloud and enter. And at the command line now, it asks me, do I want to simplify the tin surface? So here's what's interesting about what we're going to do. A lot of times, most programs out there want you to work with a grid-based decimation. Basically saying, only give me points on, say, a 10-foot grid or a 50-foot grid or whatever from that. What we're going to do is a little more intelligent than that. We're going to say, yes, I want to simplify the surface. And we're going to give it a radius. So basically your grid value, I'll just use 10 as a default to start with. But then we're also going to give it an elevation difference. I'll type in 0.2. So what it's going to say is, within this 10-foot radius, any points in the point cloud that are within an elevation difference of 0.2 it will skip. And anything that is outside of that, say a retaining wall, a ditch, curb and gutter, if your tolerance is tight enough, those points will be kept and used in the tin surface. So you're going to see in steeper areas with more terrain, more points, and in flat areas, fewer. So I'll let it run. It'll go through here pretty quickly with this because it's only that 6.4 million points that it went through. And it tells me at the command line, it's maybe a little bit hard to see on the webcast, but it gives me the number of points before, the number of points removed, and the number of points that we're keeping after the simplification. So this took me down to about 89,000. I can either create my surface from this right now or simplify it again if I don't like the results. I'm going to tell it, create my tin surface. And then it asks me if I want to densify any of these. And normally, if I was going through this in a production mode, I would probably go in and densify right now. But I want to break it into steps so that you can all see what is happening during this process. So I'm just going to say no. And it's done. We've got a tin surface. I am going to turn off the point cloud just so that we can see the tin surface and not the point cloud. So the point cloud is gone, and there's my tin surface. If I expand that, I can see under surface 1 that we added the points, we removed some outer edges, and created a snapshot off of that. Statistics, I can see the 89,000 points here. And now we have something, again, that we can rotate around and look at, really in real time. And a lot of the surface looks pretty good. These areas up here look real good. If you notice, all of these dimples on the surface, that's actually what's going on in the area. This was a data set from Slovenia, I believe. And that's a geologic feature there. They have all these sinkholes all over the place. So a lot of this looks pretty good, but let's say that our project was going to focus in kind of around this road that's in this area. And if I zoom in on that, this doesn't look so great because we didn't have enough points in this area. And even though we told it to keep points outside of that tolerance, we didn't tell it which point to keep when it did that. So we can densify this area. And I'm just going to go back to plan view to make this, again, a little bit easier to see. We're going to say our project is right through here. And if I go to the surface definition, I can just go back to add point cloud and double click on it. And we see here was the radius and here was the elevation difference that we used. I could change that right now and just reprocess it if I wanted to. There's also the densify option at the bottom. And that's what I'm going to turn that on. And I'll pick add new area. And it asks me at the command line for an elevation difference. I'm going to use 0.1. I could use 0.2 and be exactly the same as what we did before, just more accurate with that tolerance. But I'll use 0.1. And it asks me for a specific area. I can either pick an existing polyline, or I can draw an area, or I can do the entire surface. So I'm going to draw a polygon and say, I really want to densify just stuff in that area. And you can add multiple areas if you want to. It doesn't have to be just one. I'll tell it to rebuild based on that. And what it's doing now is it's taking our tin that we have, it went back to the point cloud, and it's done already. And inside of that area, it looked at every single point in the point cloud and measured an elevation difference to the triangles in the tin. And if they were outside of that 0.1 tolerance, it added those points into the surface. So just by looking at the triangles, you can see it's much more dense in that area where I drew the polygon around. And if we rotate it around and look now, you can see really how clean that road is in the area we densified. Now, sure, our tin got a little bit larger surface-wise. Statistics, now we're at 220,000 points. Still a far cry from 6.4 million, and something that I can work with here, really in real time very nicely. So if you wanted to continue and do work in BricsCAD from here out, you could. That's great. But let's say we don't want to upset whatever current workflow you have. Your goal is you had a deliverable you want in Civil 3D because your engineering department is going to take this and use it to do corridor design and grading and everything that you would do in Civil 3D. I can simply take this surface, export it to LandXML. I'll just pick it, export it. PC1 was my name. That's fine. Now I've got a LandXML file, and if I went into Civil 3D, just jumping over here, I can insert that file I just created from LandXML. And there's the surface now in Civil 3D, with the same optimized data set that we pulled out of the point cloud in BricsCAD, and ready to go on in whatever design package you'd like to use. So that is the workflow. I did get us done by 11:30 on my time here at least, but if we've got questions, I am happy to take some of those or any comments or anything that people have got there.
We do have one question. Somebody asked, can you use a geotip to define a surface like in Civil 3D?
Yeah, a geotip is, it's going to be grid-based, just like a DEM. But yes, we can get that brought in and build a surface as well.
Okay. As of right now, that's the only question. So I guess everybody was pleased with what they saw.
We're going to go with that, Steve. We're going to say that everybody was pleased and not that everybody thought this was stupid. So because I thought it was cool. Hopefully people see a good fit for that. It's one of those things. What we're seeing is a number of clients are taking this and saying, yeah, this is a specific thing in BricsCAD that we can do. We can enhance the workflow that we have currently to make a better and more optimized tin surface, and we can still use all the other tools that we're used to in whatever design package we have.
Yeah, no, I agree. All right. Well, I'd like to thank Rick for joining us today and giving that presentation showing what BricsCAD can do. And I'd like to thank everybody else for joining us. And if you have any questions, please feel free to reach out. We'd be happy to help out and answer any questions you may have moving forward. And if it's something that you think could benefit your organization and would like to have a one-on-one, we're available to do that as well. So at that, I'm going to say thank you and shut off the webinar. Have a great day.
Thanks, everybody.